7 million years ago, something walked upright on two legs across the scorching plains of Africa, and that single act of standing up changed the entire trajectory of life on Earth. Because without that moment, you would not be reading this right now. Cities would not exist. Language would never have been born. And the question of where we come from would never have been asked by anyone, anywhere, ever. The story of human origins is not some dusty academic exercise buried in textbooks and forgotten lecture halls. It is the most intimate story ever told. Because it is your story, my story. The story of every single person who has ever drawn breath on this planet. And it stretches back through an almost incomprehensible expanse of time. Through ice ages and volcanic eruptions. Through forests that shrank into grasslands and oceans that were crossed on nothing more than courage and crude rafts. Through the birth and death of entire species of humans that most people have never even heard of. Through DNA that still carries whispers of lovers who lived 200,000 years ago. And through myths and philosophies and religions that try to answer the same question long before science had the tools to even begin looking for evidence. This is a journey that spans from the first footprint pressed into ancient African soil to the microchips that may one day be embedded in our brains. And by the end of it, the way you see yourself and every other human being on this planet will never quite be the same again. Around 7 million years ago, in what is now the central region of the African continent, a creature known in modern science as Sahelanthropus cadensis was moving through a landscape that was undergoing dramatic transformation. When a research team working in the arid badlands of southern Sahara region discovered a remarkably preserved skull fossil in 2001, the scientific world was electrified because this creature appeared to sit very close to the last common ancestor shared by humans and chimpanzees, the fork in the evolutionary road where our lineage split away from our closest living relatives and began a journey that would eventually produce everything from stone tools to smartphones. Sahelanthropus was not impressive by modern human standards. Its brain was roughly the size of a chimpanzee's brain. Its face was flat and broad, and in most respects it looked far more like an ape than anything you would recognize as human. But there was one detail about this creature that stunned researchers and ignited fierce debate across the scientific community. And that detail had to do with the way it moved. Analysis of the base of the skull, specifically the position of the foramen magnum, the hole through which the spinal cord connects to the brain, suggested that Sahelanthropus may have held its head upright in a manner consistent with bipedal locomotion, meaning it may have walked on two legs rather than four. Additional evidence from fossilized leg bones and the preserved traces of ancient footprints supported the idea that this creature, or others very much like it, had already begun the revolutionary transition from moving on all fours through the trees to standing upright and walking across open ground. And this transition, as simple as it may sound, was arguably the single most important event in the entire history of our lineage, because it set off a cascade of changes, anatomical, behavioral, cognitive, and social, that would ultimately lead to the emergence of human civilization. The question of why our distant ancestors abandoned the relative safety of the forest canopy and began walking upright on the dangerous open ground has fascinated scientists for generations. And while no single explanation can fully account for such a complex behavioral shift, the most widely accepted theories center on a massive environmental upheaval that reshaped the African continent during this period. Around 7 million years ago, climate patterns shifted in ways that caused vast stretches of dense tropical forest to thin out and eventually give way to open savanna, endless grasslands dotted with scattered trees, where the rules of survival were completely different from those that govern life in the forest. For creatures that had spent millions of years climbing and swinging through branches, this new landscape presented both terrifying dangers and extraordinary opportunities. Walking upright on two legs offered several critical advantages in this open environment. First, and most obviously, standing tall allowed these early ancestors to see over the top of tall grass, which meant they could spot approaching predators, lions, hyenas, and other carnivores that roamed the savanna from a much greater distance than they could if they were down on all fours. This early warning system would have been an enormous survival advantage. the difference between life and death on a daily basis. Second, bipedal locomotion freed the hands entirely, which meant that even before the invention of sophisticated tools, our ancestors could carry food, hold infants more securely, and manipulate objects in ways that were simply impossible for quadrupedal animals. Third, and this is a detail that many people find surprising, walking upright under the brutal African sun actually helps regulate body temperature. When you stand erect, the total surface area of your body that is exposed to direct overhead sunlight is significantly reduced compared to a four-legged animal of similar size, and your body is elevated further from the superheated ground, catching more of whatever breeze might be blowing, which means you can stay cooler longer and travel farther before overheating, an advantage that would have been critical for survival in the expanding grasslands. These combined benefits created powerful selective pressure, favoring individuals who were better at walking on two legs. And over hundreds of thousands of years, this pressure gradually reshaped the anatomy of our ancestors. Their spines curved into an S shape to balance the weight of the upright torso. Their pelvises widened and tilted to support bipedal movement. Their leg bones lengthened, and their foot arches developed to provide spring and shock absorption during walking and eventually running. And their big toes, one opposable and useful for gripping branches, rotated forward to align with the other toes and provide a stable platform for pushing off the ground with each stride. But even as these anatomical changes were unfolding, a deeper question lurked beneath the surface. At what point do we call these creatures human? Sahelanthropus walked upright, or at least partially so, but its brain was tiny. It almost certainly could not speak. And there is no evidence that it made tools or controlled fire or buried its dead or did any of the things we typically associate with being human. So, where do you draw the line? This is one of those questions that seems like it should have a straightforward answer, but absolutely does not, because the transition from ape-like ancestor to modern human was not a sudden event. It was an agonizingly gradual process that unfolded over millions of years, with each generation only infinitesimally different from the one before it. And any line you draw between not human and human is ultimately somewhat arbitrary, a convenience for classification rather than a reflection of any sharp boundary in nature. In technical terms, Sahelanthropus is classified as a hominin, a member of the group that includes modern humans and all of our ancestors after the split from the lineage leading chimpanzees, but it is not a member of the genus Homo, the more exclusive group that includes our own species and our closest extinct relatives. It sits near the very base of the human family tree, more a prologue than a chapter. But what a prologue it is, because without that first tentative step onto two legs on the African savanna 7 million years ago, none of what followed would have been possible. Fast forward roughly 3 million years. And the African landscape was populated by a diverse group of hominins, collectively known as the Australopithecines. And among them was one of the most famous individuals in the entire fossil record, a small, sturdy female who lived approximately 3.2 million years ago in what is now the Horn of Africa region, and who was given the name Lucy by the research team that discovered her remarkably complete skeleton in 1974. Lucy stood only about 3.5 feet tall, weighed perhaps 60 or 70 pounds, and had a brain only about 1/3 the size of a modern human brain. But her skeleton told an unmistakable story. She was a fully committed bipedal walker with legs, pelvis, and spine that were clearly adapted for upright locomotion on the ground, even though her long arms and curved finger bones suggested she was still comfortable climbing trees when she needed to, perhaps to sleep safely at night or to escape from predators. Lucy and her kind, the Australopithecines, occupied an evolutionary middle ground between the very earliest hominins like Sahelanthropus and the later, larger brain members of our own genus Homo. They were successful and widespread across eastern and southern Africa for over 1 million years, living in small groups, foraging for a varied diet of fruits, roots, seeds, insects, and possibly small animals, and gradually developing behaviors that would lay the foundation for everything that came after. Their teeth were smaller than those of chimpanzees and showed where patterns consistent with a diverse diet, suggesting they were generalists who could exploit a wide range of food sources depending on what was available, an adaptability that would prove to be one of the defining characteristics of human lineage. And there is tantalizing evidence that the Australopithecines were already beginning to use simple tools, because stone flakes and animal bones bearing cut marks have been found at sites dating to around 3.3 million years ago, predating the genus Homo by several 100,000 years, which means that tool use, that quintessentially human behavior, may have originated not with our own genus, but with these smaller-brained, more ape-like ancestors. The discovery of these early stone tools was revolutionary because it overturned the long-held assumption that tool-making required a large, sophisticated brain. These were not elegant instruments. They were crude chunks of rock that had been smashed together to produce sharp-edged flakes, barely distinguishable from naturally broken stones to an untrained eye, but they worked. With these simple cutting tools, our ancestors could slice through the tough hide of a dead animal to get at the meat underneath. They could scrape meat from bones, and perhaps most importantly, they could crack open long bones to extract the rich, fatty marrow inside. Bone marrow was a nutritional gold mine, dense with calories, fat, and essential nutrients, and accessing it gave our ancestors an energy source that was simply unavailable to creatures without tools. Many researchers believe that this additional caloric intake, made possible by the invention of even the simplest stone tools, was one of the key factors that fueled the dramatic expansion of brain size that occurred over the next 2 million years. Brains are extraordinarily expensive organs to maintain. The modern human brain accounts for only about 2% of total body weight, but consumes roughly 20% of the body's energy. And growing a bigger brain requires a reliable source of high-quality nutrition. Stone tools provided access to that nutrition, creating a positive feedback loop in which better tools led to better nutrition, which led to bigger brains, which led to even better tools, and so on, in a spiraling cycle of innovation and biological change that would eventually produce the most complex object known to exist in the universe, the human brain. By around 2.5 million years ago, this cycle had produced the first members of the genus Homo, our own genus, the group to which modern humans belong. The earliest known species in this group, Homo habilis, whose name means handy man, was named for its association with a more sophisticated set of stone tools known as the Oldowan toolkit. Homo habilis had a brain roughly 50% larger than that of the Australopithecines, averaging around 600 cubic centimeters, and the tools associated with this species showed clear evidence of deliberate planning and design. Stones were selected for their quality and then carefully struck to produce flakes of specific shapes and sizes, a process that required spatial reasoning, hand-eye coordination, and the ability to envision a desired outcome before beginning to work. Homo habilis straddled the boundary between the Australopithecines and the more advanced humans that would follow. It was a transitional form in many ways, with a brain larger than its predecessors but still small by modern standards, a body that retained some primitive features but was becoming more human-like in its proportions, and a behavioral repertoire that was beginning to include the kind of flexible, innovative problem-solving that would eventually set humans apart from every other species on the planet. Then, around 1.8 million years ago, one of the most remarkable species in the entire human lineage appeared on the scene, Homo erectus, upright man, an individual that was in many ways the first hominin to truly look and behave like a modern human. Homo erectus was tall, sometimes reaching nearly 6 feet in height, with long legs and a relatively narrow pelvis that made it an efficient long-distance walker and runner. Its brain was substantially larger than that of Homo habilis, averaging around 900 cubic centimeters, and in some individuals approaching 1,000 cc. It was associated with a new and more sophisticated type of stone tool, the hand axe, a large, symmetrical, teardrop-shaped implement that required considerable skill and planning to produce, and that could be used for a wide variety of tasks. from butchering large animals to digging roots to shaping wood. But the most extraordinary thing about Homo erectus was not its brain size or its tools. It was the fact that the species did something no hominin had ever done before. It left Africa. For the first time in the history of our lineage, a human ancestor ventured beyond the boundaries of the continent where the entire story had begun, crossing into what is now the Middle East, and then spreading with astonishing speed across vast stretches of a Eurasian landmass. Fossils of Homo erectus have been found in the Caucasus region, across South and East Asia, and as far afield as the islands of Southeast Asia, documenting a migration of truly epic proportions that unfolded over hundreds of thousands of years and carried our ancestors into environments radically different from the African savannas where they had evolved. What drove this expansion? Almost certainly a combination of factors: growing populations, changing climates, the pursuit of migrating animal herds, simple curiosity. But whatever the motivation, the result was that Homo erectus became the first truly global hominin, establishing populations across a geographic range that dwarfed that of any previous species in our lineage. And it was almost certainly Homo erectus who achieved another of the great milestones in human evolution, the controlled use of fire. The archaeological evidence is debated, as it often is for events so far in the past. But sites in East Africa and Southern Africa have yielded traces of what appear to be deliberately maintained hearths, concentrations of ash, charcoal, and burned bone dating to between 1 million and 800,000 years ago. And some researchers have argued for even earlier dates. The mastery of fire was perhaps the single most transformative technological achievement in the entire history of our species, rivaling even the invention of stone tools in its impact on human biology, behavior, and social organization. Fire provided warmth, which allowed human ancestors to survive in colder climates and to remain active during cool nights. Fire provided light, which extended the usable hours of the day and made it possible to occupy dark caves and shelters that would otherwise have been uninhabitable. Fire provided protection, because most predators are instinctively afraid of flames, which meant that a group gathered around a campfire was far safer than one huddled in the dark. And fire provided the ability to cook food, which was perhaps the most consequential benefit of all, because cooking breaks down the tough fibers in meat and plants, making nutrients more accessible and easier to digest, which in turn means that a cooked diet delivers more calories per unit of food than a raw diet. Some researchers, most notably the biological anthropologist Richard Wrangham, have argued that the invention of cooking was the key innovation that allowed the human brain to grow to its current enormous size, because cooking essentially pre-digests food outside the body, freeing up metabolic energy that would otherwise have been spent on digestion, and making that energy available for brain growth instead. Whether or not the specific theory is correct in all its details, there is no question that fire fundamentally altered the trajectory of human evolution, and its mastery by Homo erectus marked a point of no return. From this moment forward, humans would be creatures of technology, dependent on their invention for survival in a way that no other animal had ever been. The controlled use of fire also had profound social consequences, because maintaining a fire requires cooperation. Someone must gather fuel, someone must tend the flames, and the group must collectively agree not to let the fire go out. This creates a shared responsibility, a common project that binds individuals together and rewards those who are willing to contribute to the group's welfare. Many anthropologists believe that the campfire was the original social gathering place, the first living room, where early humans sat together after dark, shared food, told stories, and strengthened the social bonds that held their groups together. The firelit circle may have been the birthplace of human culture itself, the place where knowledge was first transmitted from one generation to the next through spoken words and demonstrations, where children first learned by watching and imitating their elders, and where the accumulated wisdom of the group was preserved and passed on, creating a cultural tradition that could grow and develop over time in a way that no individual lifetime of learning could ever achieve. before moving forward in time. It is worth pausing to consider how human tool use compared to that of other animals, because it is sometimes claimed that tool use is not uniquely human, and this is technically true. Chimpanzees use sticks to fish for termites. Crows drop stones on hard-shelled nuts. Sea otters use rocks to crack open shellfish. But there is a fundamental difference between the tool use of other animals and the tool use of humans that is worth understanding, because it goes to the heart of what makes our species unique. Other animals use tools, but they rarely, if ever, make tools, and they essentially never improve tools. A chimpanzee will strip the leaves from a twig to create a termite fishing probe, but the design of that probe has not changed in millions of years. Every chimpanzee makes essentially the same tool in essentially the same way because the behavior is largely instinctive, transmitted through observation and imitation without any deliberate effort at innovation or improvement. Humans, by contrast, not only make tools but continuously refine and improve them, passing on these improvements to the next generation through teaching and language, so that each generation inherits a more sophisticated toolkit than the one before. This cumulative cultural evolution, the ability to build on the achievements of previous generations rather than starting from scratch each time, is the secret superpower of the human species. The mechanism that has allowed us to go from crude stone flakes to computers and spacecraft in a mere 2.5 million years. A blink of an eye in evolutionary terms. No other species on Earth has ever achieved anything remotely comparable, and the roots of this ability lie in the combination of large brains, nimble hands, complex language, and cooperative social structures that began to emerge with Homo erectus and would reach their fullest expression in our own species. Homo sapiens. Now here's where the story takes a turn that sounds more like fantasy than science. Because for most of our history as a species, we were not alone. We modern humans, Homo sapiens, are accustomed to thinking of ourselves as the only human species on the planet. And indeed we are today. But rewind the clock just a few tens of thousands of years, a mere heartbeat in geological terms, and the picture looks dramatically different. During the late Pleistocene epoch, from roughly 300,000 to about 40,000 years ago, the Earth was home to multiple distinct species of humans, living simultaneously on different continents, and sometimes in the very same regions, like characters in some epic saga of parallel civilizations. It is one of the most astonishing and underappreciated facts about our history that within the last 100,000 years, you could have traveled the world and encountered not just Homo sapiens, but Neanderthals in Europe and Western Asia, Denisovans in Central and Eastern Asia, Homo floresiensis on a remote island in Southeast Asia, Homo luzonensis in the Pacific Islands, Homo naledi in Southern Africa, and possibly other species that we have not yet discovered. The world was, in a very real sense, a multi-species human planet, and the interactions between these different types of humans, the competition, the cooperation, and yes, the interbreeding, shaped our species in ways that we are only now beginning to understand. The best known of these sister species is the Neanderthal, who first appeared in Europe and Western Asia around 400,000 years ago and thrived for hundreds of thousands of years before disappearing approximately 40,000 years ago. Neanderthals were physically formidable, stocky, powerfully muscled, with thick bones and barrel chests that were superbly adapted to the harsh, cold climates of Ice Age Europe. Their brains were large, averaging around 500 cubic centimeters, which is actually slightly larger than the average modern human brain. And they were clearly intelligent, sophisticated beings who made complex stone tools, hunted large and dangerous animals, including mammoths, bison, and woolly rhinoceroses, made clothing from animal hides, built shelters, and controlled fire. There is evidence that Neanderthals engaged in symbolic behavior. They made jewelry from eagle talons and shells. They used pigments that may have been applied as body paint, and in some caves, Mysterious scratches and markings on the walls have been interpreted as intentional engravings, possibly representing some form of abstract expression. Perhaps most poignantly, there is strong evidence that Neanderthals buried their dead. At a famous cave site in the mountains of the Middle East, Neanderthal skeletons were found carefully placed in shallow graves, and in at least one case. Analysis of the surrounding soil revealed concentrations of pollen that some researchers interpret as evidence that flowers have been placed with the body, a gesture of grief, of love, of some recognition that death was not just an ending, but an event that demanded acknowledgement and ritual. This interpretation remains controversial, but if it is correct, it suggests that Neanderthals possessed something that we might call spiritual awareness, a sense that the universe contained meanings and dimensions beyond the purely material, despite all their adaptations and apparent intelligence. The Neanderthals vanished from a fossil record around 40,000 years ago, roughly coinciding with the arrival and spread of Homo sapiens across Europe. The exact causes of their extinction are still debated. Climate change, competition with the more numerous and perhaps more adaptable Homo sapiens, disease, or most likely some combination of all these factors. But what is no longer debated is that Neanderthals did not simply disappear without a trace. They left a legacy that lives on inside you right now, at this very moment, encoded in your DNA. In 2010, a team led by the Swedish geneticist Van Pabo announced one of the most stunning findings in the history of human genetics, that the genomes of modern non-African humans contain approximately 1.5 to 2.1% Neanderthal DNA. Clear evidence that Homo sapiens and Neanderthals interbred after our ancestors left Africa and encountered Neanderthal populations in the Middle East and Europe. This means that the Neanderthals did not go entirely extinct. A part of them survives in us, woven into the very fabric of our genetic code, influencing everything from our immune systems to our skin and hair characteristics to our susceptibility to certain diseases. Pablo's groundbreaking work in ancient DNA analysis earned him the Nobel Prize in Physiology or Medicine in 2022, a recognition of the profound impact that his discoveries have had on our understanding of human evolution. The Denisovans represent an even more mysterious chapter in the story of human diversity. This entire species was discovered not through the traditional method of finding bones and reconstructing skeletons, but through the revolutionary technique of ancient DNA analysis. In 2008, a tiny fragment of a finger bone was recovered from a cave in the mountains of southern Siberia, a cave that had been used intermittently by various human species over hundreds of thousands of years. And when scientists extracted and sequenced the DNA from this tiny bone fragment, they were stunned to discover that it belonged to neither a Neanderthal nor a modern human, but to an entirely new and previously unknown species of human. The Denisovans, named after the cave where they were discovered, remain almost entirely invisible in the physical fossil record. Only a handful of bone fragments and teeth have ever been found, but their genetic footprint is surprisingly large. DNA analysis has revealed that modern Melanesian populations, including the indigenous peoples of Papua New Guinea and Australia, carry approximately 4 to 6% Denisovan DNA, indicating that Homo sapiens interbred extensively with Denisovans as our ancestors spread through Southeast Asia. Even more remarkably, some of the Denisovan DNA that was incorporated into modern human populations appears to have conferred significant survival advantages. The people who live on the high plateau of Central Asia, at altitudes above 13,000 feet, where oxygen levels are roughly 40% lower than at sea level, possess a unique genetic variant that allows their bodies to function efficiently in low oxygen conditions without overproducing red blood cells, a potentially dangerous response that afflicts most lowland visitors to high altitude. Genetic analysis has shown that this critical adaptation was inherited from Denisovan ancestors, meaning that a gene passed down from a species that went extinct tens of thousands of years ago is still actively helping modern humans survive in one of the harshest environments on Earth. It is a stunning example of how the legacy of our extinct relatives continues to shape our biology. in ways that we are only beginning to discover. The islands of Southeast Asia harbored yet another extraordinary human species, Homo floresiensis, discovered in 2003 in a limestone cave on a remote island in the Indonesian archipelago. The discovery sent shockwaves through the scientific community because Homo floresiensis was astonishingly small. Adult individuals stood only about 3.5 feet tall and had brains roughly the size of a chimpanzee's, earning them the inevitable nickname the Hobbit, despite their diminutive stature and tiny brains. These island humans were clearly capable of sophisticated behavior. They made stone tools, hunted small elephants called stegodon that also inhabited the island and may have used fire. They appear to have survived on their island home until as recently as 50,000 years ago, which means they were still alive when Homo sapiens was spreading through the region, raising the tantalizing possibility that our ancestors may have actually encountered them, though no direct evidence of such an encounter has yet been found. The most likely explanation for their small size is a well-documented biological phenomenon called island dwarfism, in which large-bodied species that become isolated on small islands with limited resources tend to evolve smaller body sizes over successive generations, while small-bodied species sometimes evolve larger sizes, a pattern seen in many island ecosystems around the world. In the Pacific Islands, yet another previously unknown human species was discovered in 2019, Homo luzonensis, found in a cave and dating to approximately 67,000 years ago. Like Homo floresiensis, this species was small-bodied and displayed a puzzling mixture of primitive and modern features, suggesting that the islands of Southeast Asia served as evolutionary laboratories where isolated human populations diverged in unexpected directions over tens or hundreds of thousands of years. And then there is Homo naledi, discovered in a deep cave system in South Africa in 2013, a species that has challenged nearly every assumption scientists held about the relationship between brain size and behavioral complexity. Homo naledi had a brain only about one-third the size of a modern human brain, roughly 500 cubic centimeters, comparable to a chimpanzee, and yet appears to have engaged in behavior that was previously thought to require a much larger brain. The bones of at least 15 individuals were found deep inside a cave system, in a chamber that could only be reached by crawling through narrow, pitch-dark passages, leading researchers to suggest that the bodies have been deliberately placed there, that Homo naledi was practicing intentional disposal of the dead, a form of funerary behavior that had never before been documented in a species with such a small brain. Even more provocatively, possible engravings, geometric patterns scratched into the cave walls, were reported near the burial chamber, raising the possibility that Homo naledi possessed some form of symbolic thinking. These claims remain highly controversial and are still being rigorously evaluated by the scientific community. But if they are confirmed, they would force a fundamental rethinking of the relationship between brain size and cognitive sophistication, suggesting that complex behavior may not require a large brain and may have evolved multiple times independently in different branches of the human family tree. Looking back at this period of multi-species coexistence, it is impossible not to feel a sense of wonder at the sheer diversity of human life that once existed on this planet. Multiple species, each uniquely adapted to its environment, each following its own evolutionary path, some interbreeding with others, some living in complete isolation, and all of them eventually going extinct except for one. Why us? Why did Homo sapiens survive when all the others perished? This is one of the most important questions in all of human evolution, and the answer, as best as modern science can reconstruct it, comes down to a combination of factors that gave our species a decisive edge in the competition for survival. Homo sapiens, our species, first appeared in Africa approximately 300,000 years ago. In 2017, a research team announced the discovery of Homo sapiens fossils at a site in northwestern Africa dating to roughly 300,000 years before the present, pushing back the estimated origin of our species by at least 100. 000 years from previous estimates. For most of the first 200,000 years of our existence, Homo sapiens remained in Africa, gradually developing the physical and behavioral traits that would eventually enable us to conquer the world. Then, sometime around 70,000 to 60,000 years ago, a group of Homo sapiens, perhaps numbering only a few hundred or a few thousand individuals, left Africa and began the greatest migration in the history of life on Earth. This event, known as the out-of-Africa migration, is the moment when the human story went global. From a starting point somewhere in northeastern Africa, these pioneering humans crossed into the Middle East and then fanned out along multiple routes. Some headed east along the southern coast of Asia, reaching Southeast Asia, and eventually crossing the open ocean to arrive in Australia roughly 50,000 years ago. A voyage that required the construction of some kind of watercraft and the courage to sail into the unknown. Others turned north and west, entering Europe around 45,000 years ago and encountering the Neanderthals who had called that continent home for hundreds of thousands of years. Still others pushed northeast across the vast steppes of Central Asia and into the frozen expanses of Siberia, where they adapted to some of the coldest conditions on Earth, and from there, during periods when sea levels were low enough to expose a land bridge connecting Asia and North America, they crossed into the Western Hemisphere and began the colonization of the Americas, a process that may have begun as early as 23,000 years ago based on recent archaeological evidence from sites in the American Southwest, where human footprints of that age were discovered preserved in ancient lake sediments. The speed and comprehensiveness of this global expansion is breathtaking. In just a few tens of thousands of years, Homo sapiens went from being one of several human species confined to a single continent to being the sole surviving human species occupying virtually every habitable environment on Earth. From tropical rainforest to Arctic tundra, from low-lying river valleys to high mountain plateaus, from continental interiors to remote oceanic islands. No other species in the history of the primate order, and arguably no other large terrestrial animal, has ever achieved such a rapid and complete global colonization. What made it possible? The answer, most scientists now believe, lies in a cognitive revolution that occurred sometime around 70,000 years ago, a dramatic leap in mental capability that enabled Homo sapiens to think, communicate, and cooperate in ways that no other species, human or otherwise, had ever been able to match. The physical evidence for this cognitive revolution can be seen in the archaeological record, which shows a sudden explosion in the diversity and sophistication of human artifacts beginning around this time. New types of stone tools, bone and antler implements, jewelry made from shells and animal teeth, pigments used for body decoration, and most spectacularly, the first unambiguous works of art, including cave paintings, carved figurines, and musical instruments. But the true engine of this revolution was almost certainly the development of fully modern language, a communication system of unprecedented complexity and power that allowed Homo sapiens to share information, coordinate group activities, teach skills to the young, and perhaps most importantly, to create and share fictional narratives. Stories about things that do not physically exist, but that can nonetheless motivate and organize human behavior on a massive scale. The Israeli historian Yuval Noah Harari, in his best-selling book, Sapiens, argued that this ability to create and believe in shared fictions was the key innovation that enabled Homo sapiens to build large-scale cooperative societies and ultimately to dominate the planet. The argument goes something like this: most animals, including other human species, can cooperate effectively only with individuals they know personally, which limits the size of cooperative groups to a few dozen individuals at most. But Homo sapiens, thanks to language and the ability to create shared narratives, can cooperate with virtually unlimited numbers of complete strangers, because they can all be bound together by belief in the same fictional entities: gods, nations, laws, money, corporations, human rights. None of these things exist in any physical sense. You cannot touch a nation or taste a law or hold a human right in your hand. But because millions of people believe in them simultaneously, they become powerful organizing forces that can coordinate the behavior of vast numbers of individuals toward common goals. Religion tells people that they are all children of the same God, creating bonds of trust and obligation between complete strangers. Money is nothing more than a shared fiction, colored pieces of paper or digital numbers that have value only because everyone agrees to pretend they have value, but this shared pretense makes complex economic exchange possible. Nations are imagined communities, existing only in the minds of their citizens, but they can inspire loyalty, sacrifice, and coordinated action on a scale that no chimpanzee troop or Neanderthal band could ever achieve. This ability to create and inhabit shared fictional worlds is, according to Harari and many other scholars, the single most important cognitive ability that distinguishes Homo sapiens from all other species, and it is the foundation upon which all of human civilization has been built. The evidence supports this argument in powerful ways. Neanderthals had large brains and made sophisticated tools, but their tool technology remained essentially static for hundreds of thousands of years, showing little of the rapid innovation and diversification that characterize Homo sapiens technology. This suggests that while Neanderthals were individually intelligent, they lacked the cultural transmission mechanisms, the ability to accumulate knowledge across generations and to build on the innovations of predecessors, that allowed Homo sapiens to achieve exponential technological progress. Neanderthal social groups appear to have been small, perhaps 10 to 30 individuals, and there is little evidence of the long-distance trade networks and intergroup alliances that characterize Homo sapiens societies. Homo sapiens, by contrast, maintained social networks that could span hundreds of miles, exchanging tools, raw materials, ideas, and marriage partners across vast distances, creating a web of relationships that made them far more resilient to local disasters and far more effective at sharing innovations than any previous species. As Homo sapiens spread across the globe, the archaeological record reveals the emergence of increasingly sophisticated cultural and spiritual expression. In caves across Europe, breathtaking paintings have been discovered on stone walls. Images of horses, bison, mammoths, and other animals rendered with astonishing skill and vividness, using pigments made from ground minerals mixed with animal fat or water. The most famous of these, in southwestern France, dates to approximately 17,000 years ago and contains hundreds of animal figures painted across the walls and ceilings of a vast underground chamber. An achievement of artistic genius that would be remarkable in any era. In northern Spain, hand stencils, outlines of human hands created by blowing pigment around a hand placed flat against the cave wall, have been dated to more than 64,000 years ago, so old that they may actually have been made by Neanderthals rather than Homo sapiens, which if true would mean that artistic expression is not unique to our species. In Southeast Asia, cave paintings depicting hunting scenes have been dated to more than 40,000 years ago, making them among the oldest known figurative artworks in the world. These paintings were not mere decoration. They almost certainly had ritual or spiritual significance, serving as focal points for ceremonies, storytelling, and the transmission of cultural knowledge from one generation to the next. In a cave in southern Germany, a remarkable carved figurine was discovered, a figure with a human body and a lion's head, carved from mammoth ivory approximately 40,000 years ago. This lion man figure is one of the oldest known works of figurative art in the world, and it is profoundly significant because it depicts something that does not exist in nature, a hybrid creature, half human and half animal, which means that the person who carved it was capable of imagination in the fullest sense of the word, able to conceive of and represent entities that existed only in the mind. From the same region and era came bone flutes, crafted from the wing bones of large birds, that are the oldest known musical instruments, still capable of producing hauntingly beautiful tones when played. Together, These discoveries paint a picture of our ancestors as beings of remarkable creativity and spiritual depth. People who not only survived in a harsh and dangerous world, but who also found time and motivation to create beauty, to tell stories, to make music, and to grapple with the great mysteries of existence. The spiritual dimension of early human life is perhaps most poignantly expressed in the treatment of the dead at cave sites in the Middle East dating to approximately 100,000 years ago. The skeletons of Homo sapiens individuals have been found carefully placed in shallow graves, sometimes accompanied by offerings, red ochre pigment sprinkled over the body, shells or stone tools placed near the hands. These deliberate burials speak to a profound shift in consciousness, the recognition of death as an event of significance, worthy of ritual and ceremony, and perhaps the first glimmerings of belief in an afterlife or a spiritual realm beyond the physical world. Imagine, for a moment, a small band of early humans gathered around a fire in a cave 40,000 years ago, somewhere in Ice Age North America, wrapped in furs against the bitter cold, their faces illuminated by flickering firelight, the walls around them alive with painted images of the animals they hunted and the spirits they revered. The elder of the group is speaking, telling a story that has been passed down through countless generations, a story about where they came from, about the great spirits that created the world, about the heroes who first tamed fire and learned to shape stone. The children listen with wide eyes, absorbing not just the words but the rhythms and cadences, the gestures and facial expressions, the entire complex web of cultural knowledge that makes them who they are. And when one of their number dies, taken by illness or injury or simply by old age, they carry the body deep into the cave, lay it gently in a shallow pit, surround it with flowers and shells and carefully chosen stones, cover it with earth, and then stand silently under the vast canopy of stars, speaking words of farewell to someone they loved, in a language we will never hear, expressing emotions that we understand perfectly, because they are the same emotions we feel today. The thread that connects us to those distant ancestors is unbroken. The love, the grief, the wonder, the need to make meaning out of the chaos of existence. These are the eternal constants of the human experience, unchanged across 100,000 years. The question of why Homo sapiens alone built civilization, while all other human species disappeared, is ultimately a question about the power of cumulative culture, the ability to build on the achievements of previous generations, to innovate and improve and pass on those innovations, creating an ever-growing body of knowledge and technology that no single individual or even single generation could ever produce on its own. This cumulative culture is the product of language, social learning, and cooperative behavior. And it is the mechanism that has allowed Homo sapiens to transcend the biological limitations of our bodies and brains to an extent that no other species has ever approached. It is what took us from campfires and cave paintings to cities and satellites. And it is what will determine the trajectory of our species for the foreseeable future. The modern science of genetics has given us an extraordinary new tool for understanding our origins, the ability to read the history of our species directly from the DNA that resides in every cell of our bodies. Every human being alive today carries within their genome a record of their ancestry that stretches back hundreds of thousands of years, a molecular archive that preserves information about ancient migrations, population splits, interbreeding events, and even the environmental pressures that shaped our evolution. By comparing the DNA of modern humans from different parts of the world, geneticists have been able to reconstruct the broad outlines of human migration history with remarkable precision, confirming and extending the picture that had previously been assembled from fossil and archaeological evidence alone. One of the most famous concepts to emerge from human genetic research is the idea of mitochondrial Eve and Y chromosome Adam, two hypothetical individuals who represent the most recent common ancestors of all living humans through maternal and paternal genetic lines, respectively. Mitochondrial DNA, which is inherited exclusively from the mother, can be traced back through an unbroken chain of mothers to a single woman who lived in Africa approximately 180 years ago. This woman, known as mitochondrial Eve, was not the only woman alive at that time. She was one member of a large population, but she is the woman from whom all living humans have inherited their mitochondrial DNA. Because the mitochondrial lineages of all other women alive at that time eventually died out, as some lineages failed to produce surviving daughters in every generation. Similarly, the Y chromosome, which is inherited exclusively from father to son, can be traced back to a single man who lived approximately 200,000 to 300,000 years ago, known as Y chromosome Adam. Again, this man was not the only man alive in his time. He was part of a large population, but his Y chromosome lineage is the only one that has survived unbroken to the present day. The important takeaway from these findings is not that humanity began with a single couple. It emphatically did not, but rather that all living humans are ultimately related, all descended from the same ancestral population in Africa, all part of one enormous extended family whose branches have spread across the globe over the last 70,000 years, but whose roots all lead back to the same soil. Genetic analysis has also revealed the patterns of human migration in stunning detail. The genetic diversity of modern human populations decreases steadily with distance from Africa. African populations are the most genetically diverse on Earth, while populations at the geographic extremes of human expansion, such as the indigenous peoples of South America and the Pacific Islands, are the least diverse. This pattern is exactly what you would expect if all non-African humans are descended from a relatively small group that left Africa and experienced a genetic bottleneck, a sharp reduction in genetic diversity caused by the founding of a new population from a small subset of the original. As these founding populations spread further from Africa, each subsequent migration involved another bottleneck, progressively reducing diversity. The timing of these bottlenecks, as estimated from genetic data, matches remarkably well with the archaeological and fossil evidence for the out-of-Africa migration and subsequent dispersals. The initial exodus around 60,000 to 70,000 years ago, the colonization of Australia around 50,000 years ago, the settlement of Europe around 45,000 years ago, and the peopling of the Americas sometime between 20,000 and 15,000 years ago. The concordance between these independent lines of evidence provides powerful confirmation that the broad outlines of the human migration story are now well understood. The revolution in ancient DNA analysis, the ability to extract and sequence DNA from fossils that are tens or even hundreds of thousands of years old, has added an entirely new dimension to this story. By directly reading the genomes of ancient individuals, scientists can now study past human populations with a level of detail that was unimaginable just a few decades ago. Ancient DNA has revealed that the ancestry of modern European populations is far more complex than previously thought, involving at least 3 major waves of migration and admixture. The original hunter-gatherers who colonized Europe after the last ice age, the Neolithic farmers who spread from the Middle East beginning about 9,000 years ago, and the Bronze Age herders who migrated from the steppes of Central Asia about 5,000 years ago. Similarly, the genetic history of East Asian populations, the indigenous peoples of the Americas, and virtually every other human group on Earth turns out to be a complex tapestry of migration, admixture, and adaptation, with ancient DNA revealing connections and movements that left no trace in the archaeological record. Perhaps the most audacious application of modern genetic technology to the study of human origins involves the use of gene editing tools, particularly the revolutionary CRISPR-Cas9 system, to actually recreate aspects of our extinct relatives' biology in the laboratory. Research teams in the United States have used CRISPR to introduce Neanderthal-specific gene variants into human stem cells and then grow these modified cells into brain organoids, tiny, simplified models of brain tissue that develop in laboratory dishes and can be used to study fundamental aspects of neural development and function. By comparing brain organoids carrying the modern human version of a gene with organoids carrying the Neanderthal version of the same gene, researchers hope to identify the specific genetic changes that made the Homo sapiens brain different from a Neanderthal brain, to pinpoint, at the molecular level, what was about our brains that gave us the cognitive edge that allowed us to survive and thrive while our close relatives went extinct. This research is still in its early stages, and the results so far are preliminary, but the implications are staggering. We are beginning to develop the tools to literally resurrect aspects of extinct human species in the laboratory, to bring fragments of the Neanderthal mind back to life in a petri dish, and to use this resurrected biology to answer questions about human cognition and evolution that could never be addressed by fossils or archaeology alone. While science has been systematically uncovering the physical and genetic history of human origins, philosophy and religion have been grappling with the deeper questions of meaning and identity that the scientific narrative, for all its power, cannot fully address. Every human culture that has ever existed has produced origin stories, mythological narratives that explain where people came from, why they are here, and what their place is in the cosmic order. These myths are as diverse as the cultures that created them, but they share certain common themes that reveal deep truths about the human psyche and its need for meaning. The Genesis narrative, shared in various forms by the Jewish, Christian, and Islamic traditions, describes the creation of the first humans by God, a man formed from the dust of the ground and given the breath of life, and a woman created from a man's rib. This story, set in a paradise garden, tells of innocence lost through pursuit of forbidden knowledge, a narrative that resonates with timeless human anxieties about the costs and consequences of intellectual ambition. The ancient civilizations of the Middle East told stories of humans being fashioned from clay by the gods, created specifically to serve divine purposes. Greek mythology described Prometheus molding humans from earth and water, with the goddess Athena breathing life into them. Chinese mythology spoke of the goddess Nuwa shaping humans from yellow earth. Polynesian traditions told of the first humans emerging from plants. Across all these diverse traditions, a common motif appears. Humans are made from the earth, from the same substance as the ground beneath their feet, suggesting an intuitive understanding of the deep connection between human beings and the natural world that surrounds them. Philosophers have approached the question of human nature from a different angle, seeking to define what is essential and distinctive about human beings through reason rather than revelation. Aristotle defined humans as rational animals, beings that share their animal nature with other creatures but are distinguished by their capacity for reason and their natural inclination to live. In political communities, Descartes located the essence of humanity in consciousness itself, in the capacity for thought and self-awareness, crystallized in his famous declaration, "I think, therefore I am." Rousseau argued that humans are naturally good but are corrupted by the inequalities and artificialities of civilized society. Hobbes took the opposite view, portraying the natural state of humanity as a war of all against all, in which life is solitary, poor, nasty, brutish, and short, and arguing that only the strong hand of government can save humans from their own worst instincts. Kant insisted that every human being possesses inherent dignity and must always be treated as an end in themselves, never merely as a means to someone else's ends. Sartre declared that existence precedes essence, that humans are not born with fixed nature, but must create their own identity through the choices they make, bearing full responsibility for who they become. Each of these perspectives captures something true and important about the human condition, and taken together, they reveal the extraordinary complexity of the question that seems so simple on its surface. What is a human being? The tension between scientific and religious accounts of human origins has been one of the great intellectual dramas of the modern era. When Charles Darwin published his theory of evolution by natural selection in the 19th century, proposing that humans had descended from ape-like ancestors through a process of gradual modification over millions of years, The reaction from religious authorities was fierce and immediate. The idea that humans were not specially created by God, but had evolved from lower animals was seen as a direct assault on human dignity and divine authority. The famous trial of a Tennessee schoolteacher in 1925, who was prosecuted for teaching evolution in a public school, became a landmark cultural event that dramatized the conflict between scientific knowledge and religious belief. Over the following century, the overwhelming weight of evidence from paleontology, genetics, comparative anatomy, embryology, and numerous other fields has established evolution as one of the most thoroughly supported theories in all of science. But the cultural and psychological tensions it raises have never fully dissipated. Even today, surveys consistently show that a significant minority of Americans reject or are skeptical of evolutionary theory. And in some communities around the world, the teaching of evolution in schools remains a contentious political issue. The root of this tension is not ignorance or stupidity. Many people who reject evolution are intelligent and well-educated, but rather a deep and understandable reluctance to accept what evolution seems to imply about human specialness. If we are just another species of animal, shaped by the same blind forces of mutation and natural selection that produced every other organism on Earth, then what happens to the sense that human life has transcendent meaning, that we are more than mere biological machines, that our existence matters in some cosmic sense? This is a question that science alone cannot answer, because it is not a question about facts, but about values and meaning. And it is here that philosophy and religion continue to play their essential roles, not by contradicting science, but by providing frameworks of meaning and purpose that complement the factual account. Many thoughtful people have found ways to embrace both the scientific understanding of human origins and the spiritual conviction that human life has meaning and purpose. Recognizing that science tells us how we came to be, while religion and philosophy help us understand why it matters. The discovery that we are made of the same atoms forged in ancient stars, that we share the vast majority of our DNA with chimpanzees, and even with bananas, that we are the product of billions of years of evolution on a small planet orbiting an ordinary star in a vast and largely empty universe. These facts can be received as either diminishing or ennobling, depending on the philosophical lens through which you view them. For some, the knowledge that we are part of nature rather than separate from it is a source of deep humility and connection. For others, the very fact that the universe has produced beings capable of understanding their own origins, beings who can look back across billions of years and reconstruct the story of how they came to be, is itself a kind of miracle, regardless of whether one attributes it to divine intention or to the extraordinary creative power of natural processes operating over vast spans of time. As we stand at this moment in history, looking back across the 7 million years that separate us from the first bipedal footsteps on the African savanna, and forward into a future whose outlines we can barely discern, the question of where we are going has become as urgent and fascinating as the question of where we came from. The same species that once huddled around campfires and painted animals on cave walls now splits atoms, sequences genomes, sends robots to other planets, and is seriously discussing the possibility of becoming a multi-planetary civilization. The pace of change is accelerating at a rate that would be incomprehensible to any of our ancestors, and the technologies that are emerging, artificial intelligence, gene editing, brain-computer interfaces, quantum computing, have the potential to transform what it means to be human in ways that are at once thrilling and terrifying. The historian Yuval Noah Harari, in his book Homo Deus, has argued that the 21st century may see Homo sapiens transcend its biological limitations entirely, using technology to overcome aging, disease, and perhaps even death itself, transforming from Homo sapiens, wise man, into Homo Deus, God-man. Whether or not one accepts the full scope of Harari's vision, the basic trajectory he describes is already visible in the technologies being developed today. Gene editing tools like CRISPR have made it possible, at least in principle, to modify the human genome with precision and efficiency, correcting disease-causing mutations, enhancing desired traits, and potentially redesigning the human body and brain in ways that evolution alone could never achieve. The controversial announcement in 2018 that a researcher in China had used CRISPR to edit the genomes of human embryos, producing the world's first gene-edited babies, was widely condemned by the scientific community as premature and reckless. But it demonstrated that the technology to intentionally direct human evolution is no longer theoretical. It exists, and the question is no longer whether it will be used, but how, by whom, and under what ethical constraints. Brain-computer interface technology is advancing rapidly, with companies developing implantable devices that can read neural signals and translate them into commands for external devices, potentially allowing paralyzed individuals to control robotic limbs with their thoughts, and eventually enabling a direct connection between the human brain and digital information networks. In 2023, the Food and Drug Administration granted approval for the first human clinical trials of one such device, marking a significant milestone on the road toward the kind of human-machine integration that science fiction writers have been imagining for decades. If this technology matures as its developers hope, it could fundamentally alter the relationship between human minds and digital technology, blurring the boundary between biological intelligence and artificial intelligence in ways that raise profound questions about identity, consciousness, and what it means to be human. These developments have sparked intense debate about the future of our species. Optimists envision a future in which technology liberates humanity from the constraints that have defined the human condition throughout history, a future without disease, without aging, without cognitive limitations, in which every individual has access to capabilities that would seem superhuman by today's standards. They point to the colonization of other planets as a natural extension of the same restless, exploratory spirit that drove our ancestors out of Africa and across the globe, arguing that becoming a multi-planetary species is essential for the long-term survival of humanity. Pessimists worry about a future in which advanced technology exacerbates existing inequalities, creating a world in which the wealthy can afford to enhance their bodies and minds while the poor are left behind, producing a new and potentially permanent form of biological class division. They worry about the existential risks posed by artificial intelligence that surpasses human intelligence, the so-called technological singularity, and about the potential for gene editing technology to be misused, whether by authoritarian governments seeking to create engineered populations or by well-meaning but misguided individuals making irreversible changes to the human germline. The truth, as is usually the case, is likely to be somewhere between these extremes. The future will bring both remarkable advances and serious challenges, and the outcome will depend on the choices we make as a society in the coming decades. What is certain is that the story of Homo sapiens is far from over. We are a species that has always been defined by our restlessness, our curiosity, our refusal to accept the world as we find it, our compulsion to ask questions and seek answers, and push beyond the boundaries of what is known and possible. That same drive that led our ancestors to stand upright on the African savanna, to fashion the first stone tools, to master fire, to paint the walls of caves with images of the world as they saw it, to bury their dead with flowers and ochre, to build villages and then cities and then civilizations. That same drive is now pushing us toward the stars, toward the innermost secrets of the genome, toward a future that we cannot fully imagine, but that we will create through the same combination of intelligence, cooperation, and sheer stubborn determination that has defined our species from the very beginning. The origin of humanity is not merely a story about the past. It is a blueprint for the future, a reminder that we are capable of extraordinary things when we work together, share knowledge, and believe in something larger than ourselves. Every time you look up at the night sky and wonder about your place in the universe, every time you ask where you came from and where you are going, you are participating in a tradition that stretches back to the very dawn of human consciousness, a tradition of questioning, exploring, and seeking meaning that is perhaps the most human thing about us. The story of where we came from is still being written, and the next chapter belongs to us.